My name is Claus Larsen. As Vice President for our large key account customers, it's my pleasure to introduce you to this video. If you invest just 10 minutes of your time, I will guarantee you an unmatched return of investment.
Hi, my name is Jan Felber. I'm a business developer at DEIF Wind Power. In my job, I see a lot of different levels of pain in the wind industry. A lot of asset owners complain of constraints due to rigid service agreements. My job is to find out how I can solve and ease their pains, providing them with the best possible retrofit solution for the given turbine brand. Our goal is to make turbines run better and extend their lifetime.
As an asset owner, could you imagine a scenario where you could unleash the full potential of your turbine and increase your annual energy production, get access to all turbine data, have the possibility to be independent from OEMs and do your own service? If you can answer yes to just one of these questions, you should not miss this video.
I was once contacted by a major player in the wind industry with big parks on different kind of turbines. They were sick and tired of legal issues, lawsuits and downtime on lack of service on their turbines. And they asked if it was possible for us to make a retrofit solution that would ease all those pains. My simple answer was yes, of course. And we will most likely give you an AEP increase at the end.
So what do we offer for our clients? At DEIF we have a toolbox of different solutions. We help to optimize gensets with controllers. We have tools to include renewables to hybrid projects. We work with batteries. We also help to run even marine ships with less fuel consumption. But at the wind parks we have something really special. Our upgrade solutions let you produce more energy with already existing power plants. And we develop these upgrade solutions with a big team of engineers who have tremendous experience in many different OEM brands, and we bring the latest technologies like even cloud-based AI controllers to your turbines.
When we run a 6-month validation period, generating either a weekly or a monthly report, we actually provide all turbine data to the customer in an easy to read format. It gives the customer an insight they're not used to having. And we can actually pinpoint different levels of pains through these reports. There's a very big difference in a VRCC problem on a V47 or a pitch-related issue on a Suslon S88. In the way we monitor and do the reports and having meetings after a retrofit with our customers, give them a kind of security that the turbines are running the way they should be. And this is also a result of pinpointing how we do our AEP increases. So the whole report, validation, monitoring period of a retrofit is as important for us as for the customers.
Okay, now let's talk about how we are realizing our solution. Of course, everything is starting all of the sudden with the installation. This is done by adding an add-on controller to the tower base and followed by decent site acceptance tests to ensure safe operation of the turbine. And all of this is taking, depending a little bit on the turbine type, but in a range of 6 hours. Once this is done, we are having our open access for the turbine, which ensures full accessibility and independent operation already for the service team and the maintenance team. Additionally, the controller comes with an open access for external interfaces like, for example, Modbus TCP or OPC. On top of that, we're having, of course, some DEIF tools provided, like the service manager tools for supervision, maintenance, and parameter configuration, but also our DEIF SCADA tools for local and remote supervision. Yeah, this is more or less then the basis for seeing what more we can get out of the turbine and coming to the point of the availability and the performance improvement topics. So on the one hand, we have here to improve our availability with improved alarm handling and control procedures, but also the very big point of site-specific controls. This, or part of this, is, for example, also yaw optimization, ensuring the turbine yaw misalignment, which is quite a known topic, is getting aligned fully. And, of course, also the power curve optimizations. And here, let's have a shorter look here. We are seeing here as power curve pre-drawed, a standard power curve as by turbine design, and already a little bit an outlook to the future, what is possible. And if we're thinking here about what is possible with a turbine, we have a couple of options which we can bring into. Of course, there's a start down here with an improved cut-in optimization by improved start-stop control, for example. But especially here, we have the possibility to shift the power curve, by example, making an optimized pitch scheduling, or as mentioned, the yaw optimization, taking care of having a better energy output at the middle wind area. Coming more to the switchover point, we're having here, of course, our stall detection options and a peak shaving. This will allow us an improved operation in the below rated area, but of course, as we know, we're having quite a decent operation time also in the rated speed area, or rated power area of the wind turbine. And here we're having a well-known option to make a general rated power increase, a power improvement, but also taking into consideration site-specific controls and cut-out extensions, allowing the turbine to operate longer than initially designed. How this is done is, as mentioned already, with our engineers doing site-specific optimization of the turbine. And of course, all these needs a load validation and also a lifetime validation of your turbine. Of course, all of this is added or is handled also with a third-party approval to ensure everything is within the design limits. This allows us to operate your turbine on a higher energy output per year, on a better availability, and with open access for your service team. On top of this, we're having, of course, also our park level system, which means not only the turbine is affected, but also on park side, we're coming up with our park control solution, which is a central controller installed at a point of common coupling and allowing active and reactive power control. This is especially needed for handling of grid operator demands, which are quite local, specifically locally, and of course also upcoming grid code demands. This allows all in all an up-to-date operation and open access operation of your turbine.
Hi, do you want to know how much you can get from investing in a DEIF controller? On our webpage, you can find a tool to estimate your business case and return on investment. Simply enter your turbine model and wind park data, and you will see different outputs. For example, you could select a semi-wind turbine and then set the capacity factor of your wind park or the lifespan, as well as the current wind turbine age. Finally, set up a price for the megawatt hour, and you will see your case. With this tool, you can very easily calculate your business case for different models like the Semyon, Vestas, Enercom, or Suslon. Just very simply enter your data, and you will see what is the return of the investment.
If you are interested in knowing more about our advanced control solutions for wind turbines, we would like to offer you an online session where we will discuss your project. Please do not hesitate to get in contact with us.